Okay, hey guys, this is my application problem for integration by parts. So the problem is find the distance of a car traveled in 1 hour with a velocity of vt equals t squared e to the negative t. So obviously to find this position, we're going to need to integrate the velocity function, which I have up here. So we have the integral of 0 to 1 from t squared of t squared e to the negative t times dt. So to integrate by parts, we need to do u equals t squared and v prime equals e to the negative t. Now we're not going to use the exact same method that we used in the last video to avoid integrating by parts multiple times. So I'm going to make a u column where I'll differentiate and a v column where I'll integrate. So I have t squared, and now I'm going to differentiate. So I have 2t dt, 2 dt, and 0. And so now when we integrate, we have e to the negative t. So we get negative e to the negative t, e to the negative t, negative e to the negative t. Okay. So what does this have to do with integration by parts? Well, you see, you're going to add the terms that are across. And, okay, you're gonna alternate your signs and connect the terms like so. And this is a way to integrate by parts when you have to do it multiple times. And so now we have t squared times e to the negative t, a positive t squared times e to the negative t minus 2t e to the negative t minus 2e to the negative t minus the integral, because this is a straight line, from 0 to 1 of 0 e to the negative t dt. Now we have to add our limits of integration. So we're left with this. And now when we have 0 times anything, it's just going to be 0. That's irrelevant. And all we have to do is solve this. So now we just plug in 1. So we have 1 times e to the negative 1 minus 2 e to the negative 1 minus 2 e to the negative 1. And then lost my spot. Okay, and then the 0 terms are just going to make all of this 0. So it's largely irrelevant. Actually, I lied, except for this one, which will be plus 2. And so that equals negative 5 over e plus 2. And there's your answer. So it travels this much in 1 hour.